Today we are going to talk about equivalent ratios. Let's look at this problem. A punch recipe uses 1 container of soda and 3 containers of juice to make 1 batch of punch. So right now, to make 1 batch of punch, it would be 1 container of soda, and it would be 3 of juice. That's how much it would take to make 1 thing of punch. Now, let's look here at this problem. It says draw red counters to show the number of containers of soda and draw blue counters to show the number of containers of juice needed to make 2 batches of soda. So I have a red and a blue marker. So we have to draw using the red marker. What did it say? Draw red counters to show the number of containers of soda and draw blue counters to show the number of containers of juice needed to make 2 batches. Well, over here, for 1 batch, we used 1 can of soda. So if we're going to do 2 batches, we're going to have 2 cans of soda, right? Okay. Then, if we're making that same 2 batches, how many? If we needed 3 juices for 1 batch, we're going to need 6 juices for 2 batches of punch. So now, let's look at it. We would have to have how many sodas? Count the red, 1, 2. And how many juices? 1, 2, 3, 4, 5, 6, right? So 6 would go there. So then, for 2 batches, we would have to have 2 containers of soda and 6 containers of juice. So let's just keep going. Now let's look here. It says draw red counters to show the number of containers of soda and draw blue counters to show the same containers of juice needed to make 3 batches now. Well, let's go back over here. For 1 batch, we needed 1 thing of soda. So we're going to have, that's right, we're going to have 3, aren't we? So we're going to have to use 3. 1, 2, 3, right? Now, juice, if we had to have 3, we're going to have how many for 3? There's 1, 2, 3 for the first one, 1, 2, 3 for the second one, and 1, 2, 3 for the third one. So, how many things of soda? 1, 2, 3. So put a 3 right there. How many for the juice? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would have to have 9. That brings us to what we call the ratio table of it. Okay, for 1 batch, it was 1 and 3. For 2 batches, it was 2 and 6. For 3 batches, it was 3 and 9. These are what we call the equivalent ratios, okay? They would all, if we take 2/3, or let's take 2/6, the ratio 2/6, and reduce it. If we divide it by 2, and we divide this by 2, what do we get? 2 divided by 2 is 1. 6 divided by 2 is 3. It takes you back to that beginning, doesn't it? Same way with 3/9. If we divide it by 3, the number of batches, how many batches we made of it, 3 divided by 3 is 1. 9 divided by 3 is 3. It takes you back to the beginning. So that is why 2 to the 6th, 3 to the 9th reduces back to 1/3, which makes them all equivalent ratios. Okay? Now, let me put those boards away. Take me a few seconds. Now let's look at this problem. It says to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So let's look at this table, ratio table that I have done here. Let's go back and look at the problem again. To make yellow icing, you mix 6 drops of yellow food coloring. So drops of yellow food coloring would be 6, right? Then, to make how many cups of white icing would that make? 1 cup, right? So now it is saying how much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So where are we going to put the 5 at? Does the 5 represent the drops of yellow food coloring, or does it represent the white cups of white icing? Okay, so let's look. 5 cups of white icing. So we're going to put the 5 down here. And we have to figure out what this number is right here. So if we look at it right here, to go from here to here, what do we have to do to the 1 to get to 5? We have to multiply it by 5, don't we? Well, in equivalent ratios, or equivalent fractions too, whatever you do to one of them, you have to do to the other. So in this case, we did it to the bottom number, so we have to do it to the top, or the denominator, so now we have to do it to the numerator. So 1 times 5 is 5. So 6 times 5 is what? 30. So let's see if 30 makes sense. To make yellow icing, you mix 6 drops of yellow food coloring to make 1 cup. So 6 drops to make 1. So then it would take 30 to make 5. So yes, it would make sense. So 30 drops of icing, or drops of food coloring, not icing, food coloring. Okay, so now I want you to try this problem. Joe mows lawns during his summer vacation. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns would he mow in 49 hours? Wait, let me switch off, guys. We're going to do that one in a minute, because I haven't showed you that one. That's the one I will show you. This is the one I want you doing. A patient receives 1 liter of IV fluids every 8 hours. At this rate, find how many hours it would take to receive 4 liters of IV fluids. So I'm going to give you a second to set it up and then to work the answer out. Okay, let's look at it. A patient receives 1 liter of IV fluids. So we're going to put the 1 with the IV fluids. Now, at this rate, IV fluids for every how many hours? 8 hours. So the time would be 8, and it's in hours right there, so 8 hours. It will take to receive, at this rate, find how many hours it would take to receive 4 liters of IV fluids. So where are we going to put the 4 at? It has to go with the IV fluids. So we're going to put the 4 right here. So then, how do we go from 1 to 4? What do we do to the 1 to get a 4? We times it by 4, right? So if we times that by 4, we're going to have to do the same to the 8. We're going to have to multiply it by 4. So 8 times 4 is 32. So let's see if it makes sense. A patient receives 1 liter of IV fluids every 8 hours. At this rate, find how many hours it would take to receive 4 liters of IV fluids. So if it was 1 liter in 8 hours, then 4 liters in 32 hours. So it would make sense. It fits the problem. Now the one I had before. This is the one. It says, Joe mows lawns during his summer vacation. He took 14 hours last week to mow how many lawns? 8 lawns. So 14 hours for lawns, 14 hours, and he mowed 8 lawns. At this rate, how many lawns could he mow in 49 hours? This is, I put 3 out here, so 49 is going to go here. Well, if you look at this, there is nothing that can go from 14 to 49, is there? There's nothing that multiplies by 14 to give you 49. So what can go into 14 and 18? What's a factor of 14 and 18 that's going to give you a number here that's going to help you get to 49? Well, they're both even numbers, so let's look. And 14 divided by 2 is 7. If we use 7, can that help us get to 49? It can it? So let's look at it. 14, if we go divide it by 2 here, that gives you 7. Well, if we divide it by 2 here, that gives you 4. Now, how can we go from 7 to 49? If we multiply the 7 times 7, that gives you 49, doesn't it? So then if we multiply the 4 times 7, that's going to give us 28. So if it takes him 49 hours, if he spends 49 hours mowing, that means he can have 28 lawns mowed in that 49 hours. And see if it makes sense. If it's 14 hours, he can do 8 lawns. Then we're saying in 49 hours, he could do 28 lawns. So yes, it would be a reasonable answer. And if we take 14 and it would take you back to 7/4, which 7/4 is equivalent to 14/8. So if it's equivalent to 14/8, then it's equivalent to 49/28. And if we divide, now I want you to look at this one. Cans of corn are on sale at $10 or 10 for $4. Find the cost of 15 cans. I want you to try this one. Okay, let's look at it. Cans of corn are on sale at $10 for 10 for $4. So cans of corn, we're going to buy 10 cans of corn for $4. Now, find the cost of 15 cans. Well, we're going to put 15 up here, and this is what we're trying, and this right here is what we're trying to get the answer to. Well, same here. You can't go from 10, you can't do anything to 10 to get to 15. Okay, you can't multiply it by anything to get to 15. You can't divide it by anything to get to 15. So we have a 10 and a 4. What's factors of 10 and 4? Well, they're both even numbers, aren't they? So if we divide 10 by 2, that gives us 5. Can we go from 5 to get to 15? We can, can't we? So 10 divided by 2. So we're going to divide this by 2, which gives you 5. So that means we have to divide this by 2, which gives us 2. Now we can go from 5 to 15. 5 times 15 is 3. So what's 2 times, if we times 5 times 3 is 15, then we have to multiply the 2 by 3 also. So 2 times 3 is 6. So let's see if it makes sense. Cans of corn's on sale at $10 for, 10 for $4. Find the cost of 15. Well, if 10 of them cost $4, then 15 of them can cost $6. Okay? So This is finding equivalent ratios by using ratio tables. Now, I'll be showing you different ways later on, but this is one way. I don't want to overwhelm you with more than one way today to find equivalent fractions or equivalent to answer the problems. So, I hope this video helps.